Hello, students. In this video, we'll embark on an intriguing exploration of light, a fundamental component that enables us to perceive and appreciate the world around us. Light is not just straightforward, it has a dual nature, which has led scientists to develop two main theories to describe its behavior: the wave theory and the particle theory. According to the wave theory, light is composed of electromagnetic waves that travel through space, even in the absence of a material medium, at incredibly high speeds, about 300 million meters per second in a vacuum. On the other hand, the particle theory says that light consists of particles known as photons. These photons travel in straight lines and at high speeds, which explains phenomena like reflection and refraction. Interestingly, light exhibits both wave-like and particle-like properties. Experiments in physics have shown that while wave theory can explain diffraction and interference, particle theory is better at explaining how light reflects and refracts. This dual nature is one of the fascinating aspects of light, showing that it doesn't fit neatly into just one category of physical phenomena. In terms of the laws governing reflection, they are quite simple. The first law states that the incident ray, the reflected ray, and the normal, the line perpendicular to the surface at the point of impact, all lie in the same plane. The second law of reflection says that the angle of incidence, that is, the angle at which the incoming light ray hits the surface, is equal to the angle of reflection, the angle at which it bounces off. An image, in optical terms, is formed when light rays from an object are reflected off surfaces like mirrors or refracted through lenses. In a mirror, what you see as your reflection is an image. There are two main types of images, real and virtual. Real images can be projected onto a screen. They're what you see in a cinema. Virtual images, like your reflection in a mirror, cannot be projected. Next, let's explore spherical mirrors, which are curved mirrors that reflect light differently from plane mirrors. There are two main types of spherical mirrors, concave and convex mirrors. A concave mirror has a reflective surface that curves inward, like the inside of a spoon. These mirrors are often used in makeup mirrors or vehicle headlights because they can focus light to a single point, producing a magnified and clear image. On the other hand, a convex mirror has a reflective surface that curves outward. These mirrors are commonly used as rear-view mirrors in vehicles because they provide a wider field of view, allowing drivers to see more of the road behind them. Now, let's discuss the rules for obtaining images formed by concave mirrors. When light rays interact with a concave mirror, they follow specific paths that determine where the image forms and what it looks like. For example, a ray parallel to the principal axis will pass through the focal point after reflection. A ray that passes through the center of curvature will reflect back on itself, and a ray that passes through the focal point will emerge parallel to the principal axis. These rules help us predict where an image will form and whether it will be real or virtual, upright or inverted, and magnified or diminished. The position of the object relative to the concave mirror greatly influences the characteristics of the image. For instance, if the object is between the pole and the focus, the image will be virtual, upright, and magnified, appearing behind the mirror. If the object is beyond the center of curvature, the image will be real, inverted, and smaller than the object, forming between the focus and the center of curvature. Convex mirrors, on the other hand, always form virtual, upright, and diminished images, regardless of the object's position. This is why they are so useful in situations where a broad view is needed, such as in-vehicle rear-view mirrors or security mirrors in stores. When working with spherical mirrors, we also use a sign convention to keep track of distances and directions. For instance, distances measured in the direction of the incoming light are considered positive, while those measured against it are negative. The same applies to heights. Heights above the principal axis are positive, and those below are negative. Now here's a question for you to test your knowledge. What term describes the optical illusion of an image that appears to be behind the mirror but cannot be captured on a screen? Please share your answer in the comments. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.